And with this, we come to the very end of this module where we saw how we could collect. Hi, and welcome to this module on loading and processing data using relational databases. In this module, we'll work with the Microsoft Azure Cloud Platform, and you'll need an Azure subscription in order to perform the demos of this module. We load and work with SQL data on the cloud using the Azure SQL Database Managed Service. Once we've loaded data into a relational database, we'll run SQL queries using the query editor available on the Azure portal. This is a browser-based query editor and it requires no additional installation or tools. We'll then install SQL Server Management Studio on our local Windows machine and use this tool to connect to our Azure database on the cloud. And another technology that we'll use is the Azure Data Factory. We'll see how we can use pipelines within the Azure Data Factory to load data from different sources. All of this data will be loaded into our Azure SQL database. Working on the Microsoft Azure platform is seamless. Anything that you can do on your local machine, you can do on the cloud. The Azure SQL database is a managed relational database service on the Microsoft Azure cloud platform, ideal for transaction processing applications. This offers the same SQL Server database that you might be familiar with working on your local machine, but as a platform as a service or Paas offering. The Azure SQL database is predictable and works exactly like SQL Server because it shares the codebase with Microsoft SQL Server database engine. As more and more companies migrate their infrastructure to the cloud, Microsoft is now cloud first. New features that are added to the SQL database go to the Azure SQL database on the cloud before they are added to local machine installations. Azure SQL Database is a fully managed relational database on the cloud. All of the administration and configuration requirements are mostly taken care of by Microsoft. There is no overhead for patching or upgrading your system. The Azure Cloud Platform offers a number of deployment options for your SQL database. You can deploy a single database that comes with its own set of resources managed via a SQL database server. A single database is isolated from other databases and from the instance of SQL Server that hosts the database. This is the deployment option that we'll choose in our demos. Another option is to deploy your Azure SQL database in an elastic pool. An elastic pool is just a collection of databases with a shared set of resources managed via a SQL database server. Single databases can be moved into and out of an elastic pool. Or you can choose to deploy your SQL database as a managed instance, which is a collection of system and user databases with a shared set of resources. In this module, we'll connect and work with our Azure SQL database on the cloud using SQL Server Management Studio. SSMS is available only for your Windows machine. It has been around for a really long time and is an old favorite of database administrators. SSMS has now been upgraded to work with all SQL services, including SQL Server, the Azure SQL Database, and the Azure SQL Data Warehouse. In addition to SSMS, another tool that we'll use on the cloud is the Azure Data Factory. This is a fully managed service meant for building complex hybrid ETL or extract transform load pipelines that serve to bring together data transform load building complex. This is a fully managed service meant for building complex hybrid ETL or extract transform load pipelines that serve to bring together data from disparate sources, thus integrating data silos. In addition to copying data from source to destination, Azure Data Factory pipelines can include Hadoop and machine learning transformations on your data. In this demo, we'll create and set up an Azure SQL database on the Azure Cloud Platform to work with relational data. The main portal for the Azure Cloud Platform is accessible at portal.azure.com. This is the main dashboard, which gives you an entry point to all of the services and resources that Azure has to offer. On the left-hand pane, you can expand this little arrow button here, and this brings up a navigation pane giving you access to all of Azure's resources. This is where you have the link to create a new resource as well, and that's what we'll click now in order to create a new SQL database. Go to the databases option here, and on the right-hand side, choose SQL database. This is the single database deployment option on Azure, which creates a database in Azure SQL database with its own set of resources, and it's managed via a SQL database server. Every resource that you create on the Azure cloud is part of a resource group. A resource group is simply a logical group of resources. I'm going to create a new resource group called Lunicorn -rg in order to hold the SQL database. You'll need to name this database. I'm going to simply call it Lunicorn DB, and I'm going to name the server for this database. Let's create a new server here. We don't have any pre-existing servers, and I'm going to call the server Luni. The full name for the server is luni.database.windows.net. The next step is to specify a server administration login. This is the Luni user. Go ahead and specify a password. Confirm this password. Specify where you want this database to be located. This is East US for us, and hit select. East US is a geographical region where this database resource will be located. Once you've created a database, you have the option to configure your database as well. Click on this configure databases link, and you can specify the number of DTUs and the maximum size of data that you can store here. A DTU on Azure is a database transaction unit, which is a blended measure of CPU, memory, and data input-output operations. For your SQL database. We'll accept the default size of 10 DTUs, but we'll change the data max size to be just 500 MB. We don't want to store more than 500 MB of data. Based on your configuration settings, you'll pay a different amount per month for your database. Here is the estimated cost per month for this particular set of configuration settings. Go ahead and hit apply to accept these configuration settings, and let's continue with the creation of this Azure SQL database. Click on Review plus Create. This will take you to a page where you can review the configuration settings for your database. Click on the Create button here and wait for this resource to be deployed. Once you get the cheery message that your database has been deployed, you can click on this button to go to your database resource. We'll now see how we can use this Azure SQL database on the cloud. On the left pane, you'll find a number of useful links pertaining to this Azure SQL database. And the one that we are going to use right now is the query editor. This allows us to write our SQL queries right here within the browser. You'll need to log into the database in order to use the query editor. You can use the SQL Server authentication, or on the right, you can see that Active Directory tries to sign you in automatically. I'm going to minimize this left navigation pane so that we have more room for the query editor. Observe that the Active Directory single sign-on results in an error because cloud user at lunicorn.com is not an Active Directory user. When we had set up the Azure SQL database, we had specified Luni user as a SQL Server authenticated user. Type in the password for this user, click on OK to sign in. Off to the left of our query editor is a place where you can view the tables, views, and stored procedures associated with this database. In the center pane here is where you type in your query. This is a brand new database. There are no tables in here yet. So if you try to expand the tables node, you'll find nothing in there. If you try to expand the views node, you'll find a view for the system database firewall rules. This is a default view of the firewall rules configured on the Azure cloud to access this particular database. We don't really need to worry about this. Let's type in a SQL query here within this query editor to create a new table named mobiles. This has just two columns, ID and mobile name. All queries can be executed by clicking on this run button available here to the top left of the query editor. Execute this query and a new table will be created. Click on the results option here. There are no results. Hit the refresh icon on this object explorer off to the left and you'll see that we now have a table in this particular database. Expand this node and you'll find the mobiles table has been created successfully. Let's insert a few records into this mobiles table by using the insert into SQL command. Insert into mobiles, ID and mobile name are the columns and the values that we want to insert are 2300 and iPhone X. Click on the run button here to execute this query and you'll find that there was one row inserted. The query was successful and it affected one row. I'm going to run a few additional insert commands here. This time I'm going to insert the mobile phone Pixel 3, hit run, and go ahead and insert the OnePlus 6T as well and hit run. Now we have 3 records in our table. Select star from mobiles and you'll find that the 3 records are now visible in your Azure SQL database. The query editor allows you to run a number of different queries right here within your browser. Here is how you'd update a particular record in your database using the update query. Here I update the mobile with ID 2300 to set its name to be iPhone XR. Once you've run the update command, you can run a simple select star from mobiles and you'll see that your record has been updated. 2300 is now the iPhone XR. You can also use the query editor to run delete queries on your database. Delete from mobiles where mobile name is equal to Pixel 3. This affected exactly one row. Select star from mobiles and you'll see that the Pixel 3 record has disappeared from our database. You can also connect to and work with your Azure SQL database on the cloud using SQL Server Management Studio on your local machine. In this demo, we'll see how we can set up SSMS on our local Windows machine and use SSMS to load and query data on our Azure SQL Data Warehouse. Let's go ahead and download SSMS first using this link that you see here on screen. This will take us to the SQL Server Management Studio page. And here you'll find a link to download SSMS. SQL Server Management Studio is only available for Windows machines at this point in time. Download this executable file that will allow you to install and set up SSMS. I've stored this executable on my desktop. I'm going to switch over and double click on this executable to kickstart the install process. Just click on this install button here and wait for a minute or so till the install process is complete. Click on close and you now have SSMS set up on your local machine. This little search icon next to my start button will allow me to search for this particular application. SSMS gives me Microsoft SQL Server Management Studio. Click on it to get it up and running. We want to use SSMS to connect to our Azure SQL database on the cloud. So our server type is a database engine. The next thing we need to do is to specify our server name. If you remember, when we had set up our Azure SQL database, we had specified that its server was looney.database.windows.net. Before we specify the name of the server, let's head over to the authentication options. We've set up SQL Server authentication for our Azure SQL database. We have configured an admin username and password for that when we set this up earlier. In order to be able to connect to our cloud database from our local machine, we need to configure a few firewall rules. Switch over to Lunicon DB on our Azure portal and click on the Set Server Firewall option. This will bring up a web page allowing you to configure your firewall settings. The name of this firewall rule is SSMS because SSMS is what we're going to choose to connect. Specify the IP address of your local machine. If you don't know what your local IP address is, you can simply visit whatismyip.com and this will give you your current IP address. You can specify this IP address as your start and end range. If your IP address is part of a subnet in an organization, this subnet range is what you'll specify for the start and end IP. Once you've configured access to your IP address, click on the Save button so that your local IP address has access to the Azure SQL database that you've created on the Azure platform. Remember that the resources that you create on the cloud are protected, and in order to enable access to those resources, such as this database that we have on the cloud, you need to explicitly set up your firewall rules. On this main page for our Azure SQL database, I'm now going to copy over this server name, looney.database.windows.net. This is what I'll paste in as a server name on SQL Server Management Studio. Now let's go ahead and specify the login and password that has access to this particular database. This is Looney user, and type in the password that you've created for your user and click on the connect button. Wait for a few seconds and you'll be successfully connected to your Azure SQL database on the Azure Cloud Platform from your local machine. If you click on the databases link on the Object Explorer, this will show you the Lunicon DB that we had created earlier on the Azure Cloud. And if you expand this object, you will find the mobiles table that we had created earlier using the query editor within our browser window. This is the exact same view that we had within our query editor. Expand the columns option here and you'll find the ID and the mobile name column within this table. Click on the New Query button off to the top here in order to bring up a query editor within SSMS. Here is where you'll type in the queries that you want to execute. You'll need to specify the database that you want this query to run against. By default, the master database is selected. Switch this over to Lunicon DB. We want to run the query against the mobiles table in Lunicon DB. Type in a simple query, select star from mobiles in our query editor on SSMS. Click on the execute button to execute this query. This query will run on our Azure SQL database on the Azure Cloud Platform, and here are the results. On my desktop, I have the CSV file mobile data clean.csv. This is the data that I'm now going to upload to my Azure SQL database using SSMS. Select the Lunicon DB node on the Object Explorer. Right-click and under Task, you'll find an option to import flat file. Select this option and this will bring up a dialog that allows you to import data into your SQL database. Click on the Next button here and let's specify the file that we want imported. The Browse button will bring up the Explorer window allowing you to locate this file on your local machine. Here is mobile data cleaned.csv. Open up this file. This is a file that we have worked with and are familiar with. Specify the name of the table where you want to import the contents of this file. This is the mobile underscore data underscore CSV table. Clicking on next will take you to a pane where you can preview your data. This data looks good. This is the CSV data that we want to load into our table. Click on next once again. Here is where you have the option to modify the data types associated with each of your columns. I'm going to specify that the mobile ID is the primary key for this particular table, and I'm going to change the mobile weight column so that instead of tiny int, it is an int. If there are other changes that you want to make, you can do so on this page. Click on next here so you can quickly see a summary of what you're going to import into your table. Things look good to me. I'm going to go ahead and hit the finish button and wait for all of this data to be imported into my cloud database. You've successfully created a new table in your Azure SQL database and imported data from your local machine using SQL Server Management Studio. Let's query this new table that we've just created. Select star from mobile data CSV, and here in the results, you can see all of the data has been successfully imported. Once your data is in a SQL database, you can apply complex SQL queries to extract insights and explore your data. Let's select the ID and price range from mobile data CSV, where the phones do not have a dual SIM. Execute this query, and you'll find the results here in the bottom pane of your screen. Let's try another query here. I want to find all records where the mobile weight contains the numbers 16, mobile weight like percent 16%. You can see from the results displayed here on screen that all mobiles matching this regular expression that we had specified are displayed in our results. We'll now try a slightly different select query. Select certain columns from our database, ID, RAM, battery power, and price range, where battery power greater than 1000, and we want the results ordered by RAM. And here are the results with the subset of columns that we had specified, arranged in ascending order of RAM. You can run aggregation queries as well. Let's see how many mobile phones are available in each price range in our dataset. The result of this aggregation query will show you that there are around 500 records for each of these price ranges. If you have a query that you use really often while working with your data, you might want to save that query as a view. Click on the view node here. There are no views created at this point in time. Select this node, right click, and let's create a new view. A view in a SQL database can be thought of as a virtual table defined by a query. And that query is what we are about to define here. This brings up a dialog. We want this query to run over the mobile data CSV table. So that's the table that we select. Close this dialog and let's select the columns that we want to include in this view. Use the checkboxes available here within this little editor window to select the columns that you're interested in. The first column that I've chosen here is the battery power column. You can use the scroll bar to scroll up and scroll down and view all of the columns in your dataset. Select the mobile weight column as well. Select the price range column and observe here below that SQL Server Management Studio has constructed a query corresponding to the columns that you selected from your database table. You can use the file menu and save this query corresponding to your view. Go ahead and save this view, call it the battery weight view. All of the views that you create and save will appear under the Views node in your Object Explorer. Once you have a view created, you can query this view exactly like how you would query a SQL table. Select star from battery weight view will list all of the records. In this demo, we load and query JSON data into our Azure SQL database. This is the same mobile dataset that I've been working with so far, which I've converted to a JSON format and stored in the file mobiledata-cleaned.json. Observe that this file contains a list of JSON objects as specified by the opening square bracket, and every object here corresponds to one mobile. The features corresponding to each of these mobiles is represented as a JSON object. Now you can load this data into your Azure SQL database using SQL Server Management Studio, but it's possible that your data file is present not on the local machine, but on the cloud somewhere, for example, on Blob Store on the Azure Cloud Platform. Here we are in the Microsoft Azure portal, Let's go to storage accounts and create a blob storage container. This view shows me the storage accounts that I've created across all locations on the Azure Cloud Platform. I'm going to click on this drop down, deselect the select all option, and select only the storage accounts in US East 2. You'll find that there are no storage accounts here, so I'm going to go ahead and create one by clicking on this add button here. This button will allow you to create a new storage account. Storage accounts is a Microsoft managed service providing cloud storage that is available, secure, and reliable. I have a pay-as-you-go subscription on Azure, so that's what I select here. And I'm going to select the where we've located all of our for all and click on button here to click through to the tile mobile search bar table that will hold the content. Now notice that this table has just 4 columns: ID, batch. This will Data Factory. This is a cloud integration service that allows companies to integrate data from different sources. You might have your data stored on an on-premise SQL server or on another cloud platform or in blob storage on the Azure cloud. The Azure Data Factory allows you to bring together data from these disparate data sources onto your SQL database or data warehouse. This will take us to the Data Factories page where I'm going to create a new data factory to connect to my blob storage container and bring in my mobile data onto my Azure SQL database. Let's give a name to this data factory. I'll call this Lunicorn DF. This is the pay-as-you-go subscription that I have on the Azure cloud. And I'm going to use an existing resource group. This is the Lunicorn-RG that we had created earlier. I'm using the V2 version of this data factory. That is the latest version at the time of this recording. And this data factory is located in US East 2. That's where all of my other resources are located as well. Click on the Create button and then wait for a few seconds for this data factory to be created and deployed. After successful deployment, you can click on the Go to Resource button here, and here is our Azure Data Factory that we'll use to load in data from our blob storage container. On my Here we are on the Azure Data Factory that we've just created, Lunicorn-DF. Click on the Author and Monitor option here that will allow us to create a new pipeline to process our data. This will take you to a page which allows you to configure the pipeline of transformations that you want to apply to your data. We want to copy our data from blob storage onto the Azure SQL database. Choose the Copy Data option, and this will bring up a page allowing you to specify in the form of let's go new Azure format, checks in your columns that you're interested in. We want the data in the columns. Specify the pay-as-you-go subscription that I have on the Azure Cloud. The mobile to continue to review your copy data load in data. Let's confirm whether data has actually been loaded into our SQL database by switching over to the other tab that we can query data to check whether the contents have been loaded successfully using the data database cloud platform. Into this database, you mean by installing to load JSON data to next module. Hi, and welcome to this module on representing insights obtained from data. We've got a single source and we've prepared our data. In this module, we'll talk about the different kind of numeric data that you can use in analysis. We'll talk about and see some techniques to plot continuous data. We'll understand what categorical data means and see a few examples of representing categorical data. We'll talk about other kinds of data that you might work with for analysis, such as text and image data, and we'll discuss what representations of such data make sense before they can be used in ML models. On our hands-on demos, we'll work with two specific tools. use Azure Data Studio to query and model our data, and we'll use Power BI for visualization. We'll see that Azure Data Studio is a cross-platform tool that works on Windows, Linux, as well as Mac machines, whereas Power BI at this point in time is available only for Windows, but offers very powerful drag and drop. All of the data that you work with for analysis to build data models, machine learning models, is numeric in nature. The kind of data that is used in analysis is typically divided into two broad categories. The first of these is continuous data. Continuous data can take on a continuous series of values within a range, such as house prices, stock prices, the temperatures recorded over a year, the height of individuals. All of these are examples of continuous data. The other kind of data that you work with for analysis is categorical data. Categorical data is made up of discrete values. The value assigned to your categorical variable can only be one of a discrete and finite set. True or false, 0 or 1, days of the week, months of the year. These are examples of categorical variables. Both continuous as well as categorical data have to be represented in numeric form. Continuous data is usually numeric in nature, whereas categorical data may be expressed in the form of strings or categories. This categorical data has to be converted to numeric form before it can be used in your models. Whatever features you're working with, whether it's just ordinary numeric features or text and image data, all other forms of data must be converted to either continuous values or categorical values before you can use them for analysis. And remember, both continuous as well as categorical values have to be expressed as numbers. Now that we've understood what continuous and categorical variables mean, let's compare and contrast the two. Examples of continuous variables are the height or weight of individuals. They can take on any value within a range. Examples of categorical or discrete values are day of the week, month of the year, the gender, male or female, as their names. With categorical variables, there are a finite set of a continuous variable. Classification sorted based on magnitude. Their magnitude is $1,000. Categories, on the other hand, may or may not be sorted. Male, female, really no sorting order. Are where there are just two permissible values, yes or no, male or female. Multi-class categorical variables have multiple permissible values, digits from 0 through 9, days of the week. Nominal categorical data is inherently unordered. Male or female, days of the week. There is no specific ordering here. Categorical data that is ordinal in nature may have a possible ordering. If you're talking about letter grades, an A is definitely better than a B. Text data is, well, text, but data analysis and machine learning models require your data to be numeric. In this clip, we'll talk about how we can convert text data to numeric form. Let's consider a document which is essentially just a restaurant review. This is the text that makes up this document. Model this document as an ordered sequence of words. This will involve splitting this document into words or tokenizing this document. All of the individual words of this document are extracted and set up in an ordered form. In order to convert this text document to numeric form, we'll now have some kind of numeric encoding for each word in this document. Let's say the word this is W0, its numeric encoding is X0. Then we'll have an encoding X1 for the next word, an encoding X2 for the next word, and an encoding Xn for the nth word in this document. Once all of the individual words in this document have numeric form, this document can be represented as a tensor or a matrix of numbers. Well, this sounds relatively straightforward, but the interesting detail here is how do we convert every word to a numeric representation? As you might imagine, there are several techniques that you can use for this. Here are three broad categories. You can use one-hot encoding, frequency-based encoding, or prediction-based encoding for your words. I'll now give you a quick overview of how each of these encoding types can represent text in a numeric form, starting with one-hot encoding. One-hot encoding sets up a vector to represent every word. The size of this vector is equal to the number of words in the vocabulary of your corpus, and every word in text is represented by the presence or absence of the word. A number 1 for a particular word indicates that a particular word is present in a document. 0 indicates that that word is absent. This is the simplest way to convert text to numeric format and is widely used. Let's now move on to frequency-based encodings. One-hot encoding does not tell you how often a particular word occurs in text. Frequency-based encoding does. There are three categories of frequency-based encodings. Count vector encodings, which give you a count of how often a word occurs in a document. Then there is TF-IDF encoding, where TF stands for term frequency and IDF stands for inverse document frequency. And finally, you can encode words based on co-occurrences. Co-occurrences capture how often a particular word occurs in the context of its surrounding words. Frequency-based embeddings using count frequency is just a little bit of an improvement over one-hot encoding. This also captures how often a particular word occurs in a document. Instead of using 1 and 0 to represent the presence or absence of a word, you'll say 2 if a word occurs twice in a document, or 3 if it occurs twice. These are the counts or frequencies. TF-IDF is a very popular representation that tries to capture how significant a particular word is in a document and across the corpus. The TF-IDF is a combination of term frequency and inverse document frequency. The term frequency tries to capture how often a word occurs within a document, and the inverse document frequency tries to capture how often that word occurs across the entire corpus. Here is how TF-IDF generates numeric representations for words. If a word occurs more frequently in a single document, that word might be important and it's upweighed. However, if a particular word occurs very frequently across the entire corpus, that is probably a common word like a, an, or the. In that case, that word is downweighed. You can also generate numeric embeddings for words based on how often a particular word co-occurs with other words that surround it. This is based on the idea that similar words will occur together and will have similar context. Generating co-occurrence representations involves the use of a context window. This is a window centered around a particular word, and it might include a certain number of neighboring words to the left, to the right, or both. It's possible to build up a co-occurrence matrix representation of the word using this context window. Co-occurrence is basically the number of times two words, W1 and W2, have occurred together in a context window. Of all of the possible ways to numerically represent a word, prediction-based embeddings are the most powerful. Prediction-based embeddings try to capture not only the meaning of a particular word, but also the semantic relationships that that word might have with other neighboring words. Generating prediction based word embeddings involve the use of machine learning models such as neural networks. Popular word representations generated using this technique are word2vec and glove. In this clip, we'll see how we can represent image data in numeric form so that it can be used in data analysis and to build ML models. When you work with images, you're just working with numeric matrices. An image under the hood is just a matrix, and every element of this matrix represents information for a single pixel of this image. Imagine that pixel information for an image is stored within this grid that you see here on screen. How is pixel information represented? Well, it depends whether it's a color image or a grayscale image. Color images are also referred to as RGB images, red, green, and blue. Every pixel contains RGB values which represents the color for that particular pixel. RGB values are just integers from 0 to 255. A value for R of 255 is a red colored pixel. As you can see here, the values for G and B are 0. If G is equal to 255 and the values for R and B are 0, that's a green. 250 you need to image need just one value to represent information for that pixel. Each pixel has just intensity information, and so you might say that the 0.75, there's just one to represent. Now that you've understood how pixel information is represented, here is an image. Images have height and width, which means that images can be represented using a three-dimensional matrix. The first dimension is the height, next is the width, and the third is the number of channels. Here on the screen, we have two images that are 6 pixels by 6 pixels. So the matrix shape will be 661 for the grayscale image. Remember, we have just a single channel to represent. Shape of will be 663. Color or arch dimension machine learning, you won't work with a single image at a time, you'll work with a list of images. Provided all of the images are of the same size, you can represent this as a 4-dimensional matrix. The shape of the dimension at the Wilson image, height and width presentation work, and final dimension in this 4D matrix is the number of images. It happens to be 10 here, but it can be anything. In We've already created and set up an Azure SQL database on the Microsoft Azure platform and interacted with it using the SQL Server Management Studio or SSMS. Based on your use case, Microsoft offers a host of products that you can use to interact with the Azure SQL database. We are going to work with the Azure Data Studio here in this module. We've already got a taste of working with SQL Server Management Studio, which you install on your local machine, and you can use this tool to connect to SQL databases on your local machine or on the cloud. SSMS is an extremely popular integrated environment for all SQL services. You can use it with SQL Server, Azure SQL Database, and the SQL Data Warehouse on the Azure Cloud Platform. Another option that you have is to use the Azure Data Studio. This is an integrated environment for querying and visualizing data on Azure as well as for on-premise SQL servers. Basic operations that you might want to perform are common between the two, but Azure Data Studio is designed for data professionals rather than database administrators. Let's quickly compare and contrast SSMS versus Azure Data Studio. SSMS is meant for database professionals. Those who are focused on database administration, configuration, and management. Azure Data Studio, on the other hand, is meant for data professionals, those who are looking to extract and analyze data stored in a database. The focus of SSMS is on database management, whereas for Azure Data Studio, the focus is on querying and visualization of data. SSMS has extensive wizards which you need to use when you're configuring your database, whereas with Azure Data Studio, there are not as many wizards for you to work with. At the time of this recording, SSMS is available only for Windows users, not for Windows work, whereas with Azure Data Studio. In this module, in addition to Azure Data Studio Command or PowerShell app creation capabilities, analytics app with powerful drag and drop visualization and data exploration capabilities. Power BI is powerful, simple and easy to use and closely integrated with Microsoft. At this point, we've collected all of the data that we want to work on in an Azure SQL database on the cloud.